Greetings. My name's Isaac Johnson, and this is my OpenSourceNorth 2026 talk on Let's Make an MCP Server and Skills. So the agenda, I'll talk a little bit about me, scope of the talk. We're going to talk about skills versus MCP servers and when to use and why. We're going to set up a base app, and I'm going to kind of show you how I do my coding process. We're going to build an MCP server to use that app, and then we're going to use a skill to use the MCP server to use the app. So they'll kind of layer like a cake. Lastly, we'll kind of do some diagrams and review. A little bit about me. I'm a get stuff done engineer. And now that I'm a little older, they give me titles like architect, staff, or principal. But the way I figure it, that just means I get paid to be a smartass and cranky. I talk a lot about AI. But I do have a general disdain for it because I feel like overuse is leading to skill atrophy. And I'm going to paraphrase Linus Torvalds, but it's just about being a tool. It's all just tools. And to that end, we could think about Decker. Gen AI tools are just like any other machine. They're either a benefit or a hazard. So there's 4 kinds of AI tools I kind of want to talk about or bring up. There's the AI media creation. And when that we're thinking about Lyria or Veo2 or Nano Banana, right? There's knowledge agents like Copilot and Glean and Gemini Enterprise. We have things like chatbots. You know, these are things that pop up in the bottom right of most web pages trying to get you to connect to sales. And lastly, there's the coding agents. You know, your Claude codes and your Geminis and your Copilots and your Pis and Olama code. And it's these coding agents that we're going to be mostly focusing on. The fact that it's bigger in red is just meaning that's what I want to put our energy into. But saying that, there are MCP servers for media creation. I use one for Nano Banana. And there's those that are for knowledge agents. So all that we're talking about here with MCP servers and skills equally apply to chatbots, knowledge agents, and media creation as well. I'm just going to focus on the coding side of the house this time. So when it comes to doing MCP servers or really complicated skills, you got to really ask yourself the utility, time, and cost. So how much am I really going to use this tool? Because if it's 2 times a year that you actually need some work, you might as well just do like a database dump and bring it in as CSVs to a report to build out a report, right? But if you're going to engage with a database over and over and over, wrapping it with an MCP server makes a lot more sense. The next thing is time. How much patience do you have? Sometimes you're under the gun to really make a quick report. And when that's the case, you might as well just, again, go nuts with a more complicated model or an expensive model like a Claude code with Opus 4.6 or Gemini 3 Pro. Which brings me to cost. Cost and time are closely related. You can get away with a lot with something that is cheaper. And to that end, if cost really matters, and it does for me, I should say, putting it forward, I pay the bills, so I care very much about how much I spend. I can get away with a lot using Gemini 3 Flash models or the cheap models or the low, the 4B models that are for free. So you can do things like Copilot free or I think they still have a free tier of Gemini, CLI. But realize there's a privacy trade-off. If you're not paying for it with money, you're paying for it with content. And so assume that when you're using free tiers of things like Verdant AI or others, they are going to train on your code. So that's just a cost consequence you have to think about. But at least with my Gemini account, I have a pro account, but it by default uses Flash to save me tokens. And that actually saves me a lot of money. And lastly, we can do things like self-hosted. In this screenshot, I'm not using a Chromebook, so the computer's fake. But the screenshot's real. It's hard to see there, but I've got a drop down and I'm looking at the Gemma 4 E4B, which I can run on consumer grade equipment with a moderate video card. And again, that's all about cost. If you have a video card with a decent amount of memory, you can run bigger models and do more locally. But then nowadays, the cost of a 3D card with a lot of memory is a lot of money. So you might not even be able to get the equipment if you wanted it. And again, I'm all about saving that money, and so that's why I bring this up. Skills versus MCP servers. So skills are just like reference material organized that you can fetch when needed. Think of it like a library where you go in and you look for a book, you get that information you need, and then you put it back, you return it. It's just reference material to tell you how to do something. MCP servers, and to be honest, I always wish they just called them MCP programs because there's no reason it should be a server. It can run as a Python app, an NPX. You can run Uvicorn, you can run Docker. So it's just a program. The fact that we call it server is just because there's a host, client, and server in the protocol. So an MCP server is a machine or program with specific inputs and outputs that runs when started. So it basically does a piece of mechanical thing. Put raw materials in, you get something out. It is not reference material, it is a utility. Another way to think about that is think about a workshop, okay? And if you had a workshop where you did stuff, you might very well have some books on the left with schematics and wiring harnesses and diagrams of tools that you have to do or parts you have to fix. And so you'd pull one of those books off from the left when it's time to fix something to look at, this is what the voltage should be at this endpoint, or this is what the wiring turn should be at this point. But the book doesn't solve it. It just tells you how to do it. Now when you need to actually do some work, you might grab a pair of pliers from the toolbox on the right, or, a clamp. And so the tools on the right are very much, think of it like tools in a box. They do things, but they don't really tell you how to do it. They just do the thing. And the skills are very detailed things, but they're just reference material. Hopefully that makes a little bit of sense. So in breaking down that analogy, to kind of talk about the pros and cons, or the features and drawbacks, skills use a lot less tokens. Because skills have a little header block that says when to use them, the only thing that your generative AI client pulls in is that header block that informs it when to call in the skill. And so you can have a lot of skills, many of them, and you can symlink them. So one thing I typically do is clone repos filled with skills and then symlink them into my .agents skills folder to use later. But they have to be local. Even if I've seen some examples where people put in to the generative AI, grab this skill and pull it down. But then when you've done that, you filled up the whole context with the skill, so you're not saving yourself any trouble. So skills need to be local. They need to be on your computer. And they can run code. So you can have like little backticks that say run UV this or NPX that or Docker this, but they will not handle dependencies. So they're just invoking something with permission that the generative AI can do. An MCP server, on the other hand, the consequence is it's got full context. When you load in your MCP servers, the generative AI tools have to pull in all those tools and how to talk to them and what they expect back. And so it takes a little more context to have MCP servers, which more context means slower and bigger models, right? That's what I'm getting at. But you can do things you can't do in a skill. So an MCP server can support secrets because you can pass them as environment variables or headers. You can put them in your configuration. So there's the ability to support secrets. And with the ability to control secrets, you can control access. So with an MCP server, I can say you have to have an onboarding token to use my server. Remember, a skill is just a document. So if I have the skill, I have the content. Conversely, if I type a secret into a skill, I'm just typing something plain text into a skill. A skill does not inherently have secret support. MCP servers, while they can be local, which is typically the case with a standard I/O model, with the HTTP streamable, or SSE, they can be remote. So with a remote MCP server, I can host that in Docker or Kubernetes somewhere, and it's really conducive to serverless. So whether you're talking about Lambdas or Azure Functions or Cloud Run, it's very easy to host. I'll even bring up an example, hosting things in Cloud Run. And of course, if I have an MCP server that I can run in my own infrastructure or in my own environment, it can expose private resources. So imagine, if you will, you have a small database full of customer contacts, and then the MCP server requires a header. I can expose the MCP server through an application load balancer. With the header being authenticated, it could then talk to a local database inside my virtual network or VNet and give back the data. Whereas I couldn't really do that with a skill, right? So the MCP server is a fantastic way to access and expose controlled or private data or data behind a perimeter. And you could use it for internal actions. I bring up internal actions because I could have an MCP server that says, turns on and off my Casa light bulbs. So let's break down the components of these. So a skill, at the end of the day, just needs a skill.md file. That's the minimum. You can have things like scripts, assets, and references. Here's the skill creator skill, and it's got a lot more, like it has some Python scripts, as you see. But know that those dependencies in the Python aren't necessarily handled with the skill. So you might have an issue about a library not being brought in that you'd have to then figure out with pip. Also, I have seen the use of references a lot. This one only has one for schemas MD. But a lot of times for a really big skill, I'll see the skill talk about its header, how to use it, its gotchas, error codes, and then as it describes each tool, it'll say, now look for the definition of this tool in the file under references. And that's a way that you can break down what would be a very giant markdown file in SkillMD into subsections. And the reason I bring this up is as you think about productizing these and sharing them with others, in your Git repo, you'll very likely want to break your skill down into references for the subtools so that as you're doing code reviews on your skills and updating them, you're only changing the tool section that matters. Hopefully that makes sense. An MCP server, on the other hand, is got some different invocations. So here we can see one at the top, and I can already tell that the one at the top is standard IO, because as we see here with the Docker right there, and the run is doing -i interactive. So we have Docker run -i interactive, and then it's going to go ahead and pass some environment variables. And in this case, that one's calling my Vicunja server, which is a ticketing tracking tool, and it passes forward my username, password, and my Vicunja URL. And it, of course, is picking that up from environment variables I'd have to have set in my bash RC or set before I started up my, in my case, Gemini CLI. So in that way, I have a Docker file that runs locally on my machine that has secrets passed to it and then calls out to an external system. The bottom one, the one that's Forge Joe MCP, you can see, and I can see because it says .run.app in the URL. That is a Cloud Run function with no parameters. That's just an HTTP streamable Cloud Run function that gets called out there to do some work. And you'll notice in both of these cases, I'm using something called a Gemini extension, and that allows us to have versions, because by default, these things don't have versions. And if I'm using Gemini extensions, I do have versions, and it can detect when it's out of date. But that's just a feature unique to Gemini CLI. I do not think Claude Code has the same thing at this time. All right, let's break down real quickly the model context protocol. So we have a host, a client, and a server. And in our case, with these generative AI tools, a lot of times our host and our client are bundled together. It's an SDK that's really taking care of the middle tier, that client side, to talk to the right side. In the case of streamable HTTP, we can host that out externally and scale it horizontally. And so it's more connections. And I bring that up because if we're doing standard IO, it's a one-to-one, not a one-to-many. And lastly, it's all about the deployment. We can really control things like auth, cores, and load balancing if we're doing streamable, which is why I lean into that. The middle one, SSE, I don't see on its own very much. It's usually streamable or standard IO nowadays. Again, let's break down kind of the way things work. The host through the user interaction does a handshake to the client, and it's in this way it gets all the tools. So the list tools is kind of the first thing that happens. So we get all the tools. And then as we go back and forth with the client, we're pulling the results. But it's the LLM's side to keep state and memory going on, not the MCP server side. All right, so here's our example situation. I always find it's good to have something you're building to explain a topic. In this case, we're going to make a blogging platform. It's where we're doing OpenSourceNorth, so we want to make an open source blogging platform, and we definitely want to leverage skills and MCP, and the features will have a free tier, maybe eventually a paid tier that would actually host the app. So that's what we're going to build. And I know there's people out there that love to just do the one-shotting, and that's fine. You want to just type and go, go, go. But I like to do a design, a plan, and then build in DevOps. And there'll be probably a lot of talks that you see at Open Source North and other conferences that talk all about forking to multiple agents and evaluators and deeply nested plans. But doing your design and plan first is a good way to do any sort of AI-driven code development. So the way my brain works is I need a name. I don't know why. I just need a name first. And so I wanted to pick a domain, and I picked something cheap. So .tech is cheap right now. And I was trying to come up with a good name. And a lot of times, if you want to come up with something that hasn't been taken, start to think about other languages. So Offenquell just is open source auf Deutsch. So it's just the German word for it. And that was available. And I got that domain for like $2. And so I tend to use either Ionos, which, they'll keep calling you to try to get you to pay for more stuff, but it's a very cheap registrar, especially for .coms. And Gandhi.net, which is hosted in France if you're looking for something not US based. And I've been using Gandhi since literally the year 2000, so Gandhi I've had for a long time. The next step is the UI. I want consistent look and feel through all my web pages. So I will use something like Figma or Stitch to whip it up. Now you can use like the Stitch MCP server or the Figma MCP server and engage back and forth that way. But there's this new kind of format called design.md. It is open source. It is not unique to Google. So if you do this design.md, and I know I can do it if I do things in Stitch, I can do I won't show you here, but I can download the design.md file. That defines all the fonts, the screens, the sizing, stuff like that. And then my UI tool, my generative AI tools, can consult with that design.md as it builds each subsection or each new UI element. And I found it does a good job keeping things looking correct as I build out a web-based site. Another thing that I tend to use is Coder. So Coder is open source. Actually, it's kind of funny. So I was talking to the CTO of Coder when I was at GCP Next just a few weeks ago. And he's like, yeah, let's talk in Minnesota. I'll be there for an open source conference in May. I'm like, fantastic. I'm speaking at that one too. And we had like this great thing. Hey, I'm gonna mention you in my talk. Find out he's at the other open source convention going on just a week prior, downtown Minneapolis. And this one here, OpenSourceNorth, is in St. Paul. So funny little near overlap. But regardless, I use Coder a lot. I like Coder. You can run it in the open source version very easily. And essentially what it is it's kind of like GitHub code spaces or dev containers if you use that in VS Code, where you can have a containerized host for code server. And the reason I like this is it runs on my cluster. I can resume it, and then I can access this from any computer. Because for me, I dance between computers all the time. I'm sometimes on a laptop, sometimes on my desktop, sometimes on my work computer. And I don't want my personal stuff mixing with my work stuff. So this allows me to have containerized hosts, in my case, running in Kubernetes. But you can run in Docker, you can run in clouds. And then what I can do here is I can do things like leverage Gemini Code Assist. I can leverage Continue Dev. And I can leverage Copilot just as easily inside these code servers. So here I have Copilot, and I can easily add an MCP server into my code server. Lastly, my pro tip, I tend to use the free models or the cheap models as much as humanly possible, or just code it myself, right? I generally start something basic, and then I just kind of iterate. But then when I need help with the complicated bits, that's really where I tag in the big boys. So that's where I'll pay for an expensive Anthropic model through Claude, or I will use my Gemini 3 Pro model. And in my case here, I really suck at database migrations. I'm just owning that, okay? I know what I need to do. I can never get my brain wrapped around how to do it. So when I was trying to do database migrations for this offenquell.tech website, I asked to help me with that, and it helped build out the Alembic configuration, and then update the migration DB job and my Kubernetes that can run as an init container and work all that out for me. And I kind of needed that help. I needed that senior level help. A junior engineer wasn't going to help me. And so I definitely use tools like Gemini CLI for that. And again, I know I'm a GDE, so I lean in on Google stuff, but the version of I just have the AI Pro account, which I got free with a Pixel phone, and I'm only using 2% of my quota. That's 2% of my quota for my database thing for a day. So I get a lot out of that. I really do. Lastly, I'm a DevOps guy. CICD for all the things, right? So in this case, with each build, I'm iterating on it, and I'll build the Docker file and I'll push it up to Harbor, my own container registry, and I'll often push it to Docker Hub to make it very easy to share with others. And I bring this up because I've witnessed enough people that don't do the Git, they don't do the checkpoints, they don't do the CID, CD, and they just keep vibing. I'll just keep vibing. I don't need to check in yet, and then kapow. They've blown a whole lot of budget and a whole lot of tokens with nothing to show for it because they've made a big mistake, the thing doesn't work, and they don't know how to roll back. So now in the last stage of my iteration, I'm ready to really test this live, not just in Docker. I'll create an A record, I'll fire up the Helm chart, and then I'll iterate with it. I'll test and iterate and then relaunch with Helm with new values. So I can always roll back to the last. So let's see an example. Here I can log in with Google. I can go to my dashboard. I can see my auth token. And now I can go click in here and set my short name. If I go back to the main site, let's see, go back to the main site, click home. If I click Docs, I can see the Swagger and Open API or Swagger. So this is what the Swagger looks like. And I'm still calling it Swagger. I know the right word is Open API. I am old. Let me call it what I want. So here's Swagger, which I get for free because I used the Fast API framework when I made my Python app. And to be honest, I have a skill that says exactly which frameworks I like. And they, for Python, use Fast API, which will give you docs and redocs. So here I do publish, I pass in my token, and then the response is going to give me back a full Kubernetes manifest I could launch into a cluster. Now here's the idea. The idea would be at a pro level, this would actually create the namespace because that's in there in that manifest and launch their container into the cluster and host their blog for them. So that's where we'd want to go. But for here, I feel like we've made enough of an app that we can now think about how we do an MCP server for it. And of course, there's the URL for the docs page you could click and see if you wanted to. So cleanup. My last step that I always like to do with any project is to kind of clean up those containers. So here we can see Harbor scanned it with Trivy and found some high vulnerabilities. And we can see the CVEs listed here that are all high, and hopefully we can do something about that. So that's when I had the thought about using Playwright MCP and Browser MC with Gemini CLI. So you can see here I say the image is built with Docker in the app. It has vulnerabilities. Use Browser MCP, which I find works really good with WSL, whereas I don't see the same thing with Playwright with WSL. And I log in and I get the results. It's going to ask, hey, can I use Browser MCP to log in here? And there, download all those CVEs. It got the list of CVEs. Gemini then examined my container and looked at my libraries and then smartly said, hey, you should do an apt update, app upgrade. And a part of me thought, well, I could have done that. I'm not really sure what that provided. But that's what its guidance was, and it's a pretty good showing of how to use Browser MCP. And I want to point out this really good code lab by my fellow GDE, Darren Lester. He showed at GCP Next a few weeks ago, and it was one of my favorite presentations I had. And so just this code lab will take you through how to set up Playwright and Browser MCP with Gemini CLI. Now, cleanup does not always mean remediation. So in our case, we went from 118 with highs to 222 with criticals. We essentially made it worse. And so sometimes the right approach is, I find, to stop vibing and pull my head out of my butt and use my brain and think about whether the problem has been fixed already. And that's where I come to ChainGuard. So ChainGuard, who is a sponsor here at OpenSourceNorth, has freely available hardened images you can get, open source images, and I'm using the ChainGuard Python latest dev as my base. And then from here, I'm doing copying forward my virtual environment directory, my app directory, and because I'm using Alembic for my database migrations, I copy the Alembic over. And then I host it with Uvicorn and host 000. And once I switched over to using a ChainGuard system, you can see in the blue text, no vulnerabilities. It took care of all my vulnerabilities. Now, they're a commercial company, right? So everything is free and open source for the hardened images, but it's hardened and no vulnerabilities as of this moment. There might be some later. So if you want to get the automatically remediated images as well as alerts and support, you can engage with ChainGuard for commercial support at a reasonable price. And so, I don't know, it's a tip of the hat to ChainGuard, who I think makes a very useful product for me. Now we're going to move on to building the app. So when we build an app, I like to think of kind of the skateboard, scooter, car approach. Build something iteratively, a piece at a time, as opposed to trying to build the whole car at once where it's not usable until the end. And it's just kind of a paradigm I like to talk about when I build up something new. So as we build this MCP server, the crawl, or the skateboard approach, is going to be, let's make something that runs in Python. Let's serve a greeting to the user, and let's be able to run this on other hosts. And with all our things, we're going to save this in Git. Now, my setup with Git is almost the same way each and every time. I make a Git directory. I do a gitignore file. Here I do Linux and Python. Now, I've been using gitignore.io since 2016, but it's an option you can use for anything. I then do a git init, and then you're going to see a branch. I create the main branch. I touch or create a README file. I add the gitignore file I just made, the README file, and I do my first commit. And I just bring this up because this is my development flow with new work each and every single time. Now, we don't need to vibe code or use tools to make the MCP server. It's really this simple. You do a virtual environment in Python, you activate it, you install FastMCP, and now when it comes to creating the server, it's really just these handful of lines of codes. We import FastMCP, we give it a name. Here I've given it the name of OpenSourceNorth 2026 MCP server. And then each tool definition starts with an @mcp.tool. So here you see def greet name. I'm going to take in a name of type string, and I'm going to be returning a string to the user at the end of this. And usually there's some code in between that def and the return. In this case, there isn't. I just return a formatted string of hello name. The last couple lines in a Python FastMCP file are always the same. If name is main, do an MCP run. In my case, I'm doing HTTP streamable. So you can see the transport's HTTP and the port is 8000. Now, if I wanted to do standard IO, I could just do mcp.run with parentheses, and that would do a standard IO server. I do Python to launch and see, wow, it's running on 127, serving up 8000. But because my WSL has some NAT networking issues, I'm going to go ahead and immediately move this on to revision control. So I'm going to use, the best in class when it comes to open source revision control. That's Codeberg. So I'm going to use a new repository here. I'm going to create the repository, making sure I keep it public. And I'm going to add my origin and then do push, and then -- all pushes all branches up to there. Now I'm going to go to a real computer that isn't running Windows. And I'm giving this comment right now as I record this for the 5th time in Windows, which keeps messing up the audio. So my disdain for Copilot OS is getting stronger and stronger. But I digress. I git clone the repo, And then I realized quite immediately I forgot to put fastMCP into a requirements file. So I put fastMCP to the requirements. I do a virtual environment, activate it. I did upgrade pip this time, and I do pip install -r requirements. And the reason I do that is you ultimately over time will update your requirements with all your libraries. And then I run Python server py. And I immediately am reminded this Linux host was already running an MCP server in Docker, I might add, on port 8000. So I can't use port 8000. So what I do here is I update the port to port 8088 and I relaunch it, and that's good, but then I'm not able to reach the host. And that was when I realized I need to serve all traffic. So I need to add in that host equals 0.0.0.0 in my MCP invocation to serve up on all interfaces. And now I have a server running on the Linux box. Let's see a demo of this. So here you can see the builder, the host. It's running 000 MCP. And now I can go to my coder instance and start up both namespaces. So here you can see I start 2 different sessions. Now they're running, but then it dawned on me that that Jekyll blog test is a really large container. It has like a 12 gig repo. And I don't want to waste the space. So now I'm just running my test. I could launch Code Server right there, or I could click into here and launch Code Server and fire it up. So now I got Code Server running in a browser. And I can go to Copilot, click Add MCP. Oh, clicked out of there. I'm going to do type HTTP. Now here I should have typed in http://192.168.1.143:8088/MCP. But for some odd reason, I gave it a name. I'll correct myself in a moment. And then I always say remote. That's mostly because I've gotten the habit when I'm in WSL, I need to do remote. So now I look at here, I immediately see my mistake that URL is a name. I'm just going to delete this because I did this once already. And I have the right entry above it. So you can see the 192.168.1.143. And again, this is in a different host. This is running in Kubernetes. So I can see it's already working because I see 1 tools. Now I'm going to show output. And it takes a moment. So I'll do it again, but then we're going to see it in just a second. And you can see the tool greet does not have a description, but that tells me the greet tool is running. And I can see a 200 response code coming from the server. So now I'm going to say use, and I'll give it the name of the MCP server to be real explicit. And I could tell it use the greet tool or say something like to greet me, which should trigger it to use the right tool. There's only one. And Copilot says, hey, do you want me to say that your name is user? And I say, yeah, go ahead. It says, hello, user. And there's my response from an MCP server. Next, we'll test it in Gemini CLI. Now, my Windows subsystem for Linux always gets its node version mixed up. So I go back to JOD, and I do MCP add, the transport HTTP, and actually all these CLI tools use kind of the same syntax. And now it added an MCP server. So I can fire up Gemini. I can say /MCP list. And scroll up here, you can see a lot of the MCP servers I have. And there's my greet tool under the MCP server. I don't need to run it again, but now you've seen it in Gemini CLI. Now let's talk about building an MCP server. We want to make it useful. It should use the REST API of OffenQuell. It should cache the auth, and it should let us do things like get tokens, reset, deploy, etc. So we're going to do this iteratively. So what I do is I make a small change. In this case, I'm using Gemini CLI. And what's really nice is you can see here at the top, I said this MCP server defined in server py needs to expand to regenerate the token. And I give it the token path, update the short name. Again, this all comes from the Swagger. And I say, you can fetch the Open API spec here at the URL. So I've given it all the tools my coding agent needs to actually make an MCP server, to expand that Hello World one to do more tools. And as it updates, I'm making it live because I'm doing this remotely on that Linux box and restarting Python. And I'm checking down here in my coder instance, oh, I see now 3 tools, and I'm restarting it and it can catch any errors. And of course, as I go along, I check into Git all the time. The other tool I really want to bring up is MCP Inspector, which we can launch with Model Context Protocol Inspector. And this gives us a lot more detail. So here you can see I put in the URL on the left. We can see the regenerate token, update short name, greet, and then I can run it. So I passed in a name of Peter Gibbons, and I ran the tool, and then I got back, hello, Peter Gibbons. What's happening? And as I iterated, I worked through some auth things, so I can start to handle more things like API keys, custom headers, and whatnot. That brings me to actually talking about the auth. A really common way to pass in auth things to an HTTP-based MCP server is with the headers. And usually you start your header with X-. Now here I'm using X- API key. I use that with my Perl MCP, which does some stuff for me. And here I'm using it down in the one running in Docker. So I passed in the API key. And again, you can see it working, passing it forward. I want to talk a little bit about the code here. So what you can see here, let me bring it, is I take in that X API key way up here and again down in here. And I'm passing it to headers here and headers here. So I pass in the X API key, and in the line below it, I add it to headers. And the thing I found is that Fast API, which was in the app, was responding to responses like dashboard with a full HTML page. Well, that doesn't really buy me anything. That blows up my context huge. It would make my generative AI tool not all that useful. I might as well use browser MCP then. So what I used is this beautiful soup thing, which is a Python library to parse HTML. And then I pull out the short name from the header from a input value, and I pull out the H2 for the auth token. And so in such a way, I respond with JSON. And if you make your MCP server respond with YAML or JSON, you're actually going to build some real value, because those are formats that most generative AI coding tools really handle well. So lastly, we're going to build the kind of the run stage, the crawl, walk, run, is we're going to refine it. We're going to handle the auth, which I've touched on, CICD, and we're going to host it in Kubernetes. Then I'll demo it in Copilot, Gemini, CLI, and Claude. So now let's talk about the auth. Let's see this in action. So here you can see I have the URL and the API keys right there. So I'll say, using the MCP server, use the tool to get the site short name, and it's going to pick up that auth and talk to the server. It gets the dashboard and it says the site short name is Isaac App. So let's talk about the CICD. So with Docker, we can do, a build and push, and I push it up to Harbor, and I push it up to Docker Hub. And you're going to notice there's some sections there with Dockerfile and tail and sed. What that comes in from is in line 42 here, the last line of my Dockerfile. I will always put the URL to my destination container, whether that's ACR or ECR, GAR, Harbor, and the tag. And then it can parse that and push it easily using those commands. Now, if you're in a system like I am with Codeberg, where my runner doesn't have access to the Docker ship, it's a low privilege container, you can use something like Kaneko to build a container and push it. Now, I know Kaneko is end of life, but it's still working. I still use it. It was kind of the basis for code build. And I will push it out there. Now, there are a couple alternatives like BuildKit and Build-A, which I think maybe is somebody's fun with a Boston accent like Build-A, but Build-A and BuildKit are other options for pushing out. I tend to use Kaneko just because it works really, really well. Now that I push it out, we can see it in my public library on Harbor, as well as in Docker Hub. And the thing about Docker Hub is, it's free. So if it's free, there's a limit, and that means they rate limit on your pulls as they need to do something. So you can find it there under my Docker Hub. So let's talk about demoing it in Copilot. So here you can see I have the server. And I'm just going to give it a better name like OffenQuell, because now I have it hosted in Kubernetes. I can use TLS and say HTTPS, give it my URL, which is mcp.offenquell.tech, and I'm keeping the key the same. So I'll hit start, and I see a 502 bad gateway. What's going on? Oh, maybe I don't need the MCP part. So I'll remove MCP, start. Nope, still a 502 bad gateway. We'll add it back. Something's going on. So we'll bring it up, and I see not found, right? So, okay, so I don't have a health check. Let me switch this over to MCP. I'll do a Helm upgrade. And, oh no, now I get 406 not acceptable. So I bring this up because you may find that these HTTP gets don't really work so well with MCP servers. So instead, what you can do is change it over to a TCP socket, and then just give it the port. I could have left the port HTTP because I defined it as 8000, but I'll say port 8000. And you can do the same thing for the liveness probe here as you do over in the readiness probe. Then I do in the readiness probe, same as liveness. I always update my chart version. And now when I relaunch, I see the containers running. And more importantly, when I go to the server and restart it, you'll see indeed there are 5 tools running, which tells me it is working. You can see that in Gemini CLI, I launched Gemini CLI. And what I'll do here is I will say Gemini MCP add scope a user, because I can say scope user or scope project. And then I will do the transport. So the scope user project, transport HTTP, the name, and the URL. And last time I showed you going into Gemini and doing /MCP list. We can just do Gemini MCP list and see our configured servers. So now let's go ahead and see what this looks like in Claude. So I'll say Claude MCP add transport HTTP. And you'll see the syntax here is the same as Gemini CLI. So I'll give it the URL. And then when I launch Claude Code here, I can do /MCP. And if I type in list, which it doesn't show it in the prompt, but I say list, I can see OffenQuell is connected. And now I could do the same thing again, engage with the server. Now let's move on to building a skill. So for this, we're going to use the MCP server, and we're going to test it with the MCP server. So the first block is, you can see the OffenQuell MCP integration. And then we have a description here of interact with the server. And it's very important to get this description right. I can't stress that enough. So you'll see here that we say use this skill when the users, because it's important to kind of talk through, because this will tell the generative AI tool when to pick it up and when not to pick it up. It talks about regenerating the API token, updating their short name, and then with the compatibility, I say it requires the MCP server connection. Now what I should do is remove that with base URL and MCP debug, because that doesn't matter. Our skill doesn't need to know about those details. So that could be some optimizations I do with the skill, is reducing the words on the compatibility. I then get a skill definition and an overview. And it's in the overview that we start to talk about all of our tools. It would be here that I then make references to the reference documentation, say the get dashboard skill is defined in the references /dashboard MD. So you could break down your skills. I won't do it in our example. Instead, I'll talk about the authentication, when to ask for it, treat it as sensitive. And now here you see the tool definition. So I say use this when, I say the tool get dashboard, and I tell it what it does. It's going to fetch the dashboard and extract these two pieces of information. And then I show it an example interaction. Hey, show me this information, and then go get the API key and call it. And then the response format there tells my generative AI tool, this is what you're expecting to see back. Now I define the update short name tool. I won't go through every tool because they all kind of look the same, but we know what it does, example usages, example responses. And at the end, I will cover some common errors and responses. It says, hey, if you get a 401 unauthorized, it's probably that the key is invalid or missing, so just verify the API key is correct. So we can kind of tell the tool how to prompt us to see if things are working. Lastly, we have some security notes and integration notes. All right, let's do a full demo here, end to end, about how this works. All right. So I'm going to start the video here, and we're going to see, first, I'm going to look at my agent skills and see the skill MD here. And as I scroll through it, you're going to see that it has the name and the description. It's got the compatibility. You're going to note that everything's the same as what we just showed, as well as showing me each and every tool, like a dashboard or generate token. So the skill looks good. So now I'm going to fire up Gemini CLI. And my first thing I'm going to do is just see that my skill is listed, skills list. And indeed, my skill is right there, OpenSourceNorth MCP integration. Great, my skill is good. So the first thing I had as a thought was say, use the OpenSourceNorth MCP integration skill. And I was going to type this all out. And I thought, well, that doesn't really show you the value of this thing, right? It'd be far better if I just saw if it picked it up. I'd like to know my OpenSourceNorth short name. So this kicks in. It's thinking. It says, hey, I think I have a skill that'll do this. And I say, yes, go ahead, use my skills. It says, hey, I need your API key. Remember, with Gemini, I didn't pass it. So I'll copy and I'll paste it. Hit enter. And it's thinking, and it says, hey, I think I can use the MCP server. I say, go ahead and use it. And it came back with null. And you can see right there at the end of G, somehow an M dash got in there. So it says, hey, I think your key is invalid. Can you paste it again? So I'll paste it again. This time there's no M dash. And it got back the key and says, your OpenSourceNorth short name is Isaac App. And now in this way, I've given you a full end-to-end demo. All right, let's look at diagrams. So you're going to see here what we built are two things. The app, which is in Codeberg, but it's private. I'm not sharing that. Git repo. And then we have the MCP server with the skill in it, and that's in a public Codeberg Git repo. Now, I could have had that Codeberg in my Forge Joe or Gitea in my Kubernetes cluster, but here I'm hosting it where everybody can reach it, and it's a little more reliable. I have Docker builds, and they're building the container and pushing it to Harbor CR and Docker Hub. And while I'm showing in the diagram Harbor CR kind of outside of my cluster, technically speaking, my Harbor is running in my K3S cluster. So once I have the containers built, I then use Helm charts to deploy them into the MCP server and app. And now my users access them with the Nginx ingress controller. And I bring all this up to say, the Git could be in my K3S. The Harbor is in my K3S. My build servers are, technically speaking, in Docker hosts in my network. I can do all this self-contained and not rely on anybody. And it's just a really important thing to validate that a lot of this open source stuff can be done without relying on any vendor whatsoever. Now, as far as usage goes, you can see my skill was hosted over in Codeberg, but that could be GitHub or GitLab. And then once I had that skill, I pulled it in and I used it in the web-based coder. I can do it in Gemini CLI or, Claude on the laptop. And I can use it in Copilot in VS Code or Continue Dev or GCA on VS Code. So all these things can use my skill, and they all talk to the MCP server to talk to the app in a reliable way. So in summary, MCP servers are just programs that let us access systems and data. And they're easy to host in Docker, Kubernetes, the cloud. I didn't show you a Cloud Run, but there's easy ways to run it in Cloud Run. Skills are just markdown-based guides that shape how our tools work. They have kind of references and help. and they're just reference material. But what I would like to make an argument here that I don't see as many people doing is that skills are complementary to MCP servers. They work well with MCP servers. So a skill plus an MCP server makes a very complete offering. All the code that I just showed you is over in my Codeberg repo under ID Johnson OSN2026 MCP demo, as well as the skill there is in the skills folder. So feel free to grab that and use it however you see fit. Additional resources. There's a link here to the Firebase CLI. I didn't show that one, but there's a code lab by Luke Schlangen that is really, really good. It is how to create a Gemini CLI skill and use it in Firebase CLI. And the other one that I really want to bring up is the browser MCP and Playwright MCP code lab. I mentioned that earlier in this presentation, and that was by Darren Lester, who's a GDE, and I saw that one at GCP Next, but he has a code lab there at codelabsdevelopersgoogle.com/agentic UI testing. And that was a really great way to get used to how to use both those tools in Gemini CLI. My blog is at freshbrewed.science, and you're always welcome to email me. My email addresses are right there. And thank you so much for watching.